Hi, welcome back. So we're now at part 6 of this tutorial series for Proximal One, an interactive audio system for Unreal Engine. And in this video we're going to be having a look at the filters and the different filter types and how we can apply them. So I've added this audio instance into the level, and I've also changed the audio sample that it plays to this one. So using a saw wave melody, because a saw wave has got really nice harmonics, so it will demonstrate the filters quite well. Right, so also we just want to make sure that we've got enable live editing ticked, so that'll enable us to hear the changes that we make after we hit play. Okay, so the first thing that we're going to want to do is come down to where we've got visual components, and we're going to change that to filters. So when that's set to filters, the visualizer will give a color representation of where the filter cutoff is. So the default setting, if you come down to where it says filters shared settings, the filter cutoff method is set to player proximity changes cutoff. So what that means is, as the player comes in, as the player moves through this collision box, it is going to change the filter cutoff, and the color that we're seeing represents what the current frequency is at. So as an example, if I come down to where it says proximity settings, you've got a minimum frequency and a maximum frequency. Now if we were to change the minimum and maximum, you can just about see it. It might be slightly overexposed. We can just come into the clock blueprint actually and just bring down the brightness of that visualizer. I'll come back to it. So yeah, so you've got the entire rainbow representing the range of frequencies from 20 Hz to 20 kHz. Okay, when we change the filter cutoff method to static, it means that the cutoff will no longer be changed by the player's position in that collision box. And in the next setting, in the next category where we've got general settings, we can set the cutoff frequency here when it's set to static. So with that set to static right now, if I hit play, if I leave it disabled at the moment and then hit play, and we can enable the filters and go through the different filter types and have a play around with the cutoff. So let's do that. So filter types. Currently it's set to a low pass filter, and what that means is basically any frequency above that cutoff frequency value is going to get filtered out. So we can demonstrate that. Oh, I need to enable it first. Let's start right at the top and then enable it. So okay, so you get the idea of what that's doing. Now if I change it to high pass, it will do it the same but the opposite. So any frequency below that value is going to get filtered out. So If we move that up now, and then you can hear it's gets quite high at the top. So what else have we got? We've got band pass. So band pass is, it's kind of like a combination of low pass and high pass. So you have a band in the middle which is not filtered out, and everything else is filtered out. So if we set that to that, so you've got this thin band in the middle. Okay. And then we've got notch, which is, it's kind of the opposite of band pass. It's kind of, so if you can imagine, like, you've got the frequency range and then you've got a bit scooped out of it. So that's what notch would be. And so this would, the cutoff would determine whereabouts that notch is. Okay. And then we've got low shelf. So if we try low shelf, so if you can imagine all the frequencies below this value will be moved, will be boosted or cut. And to boost or cut, you would use this setting here, the gain. So if I was to pull that down, you can hear that everything below that frequency is being attenuated. And if you boost it, then it's going to boost everything below that frequency. Okay. And the same thing for high shelf, but in that case, everything above that frequency is going to boost or get cut based on the gain value. Right? And then we've got another low pass and another high pass, which essentially do the same as that, but they're just, it sounds a little bit different. I'm not sure exactly what the difference is, but it's a similar kind of thing. Right. So the next one, we've got parametric EQ. So parametric EQ is basically like an equalizer. So you would use the gain control with that again, and so you would pick the frequency that you want to boost or cut. So like that. Okay, and then we've got this one, bandwidth. So if we set that back to low pass, and this will sort of control the slope the cutoff has. So if you can imagine that everything above certain this frequency is passing through, but everything below it, everything below it is passing through, and everything above it is getting cut off. The area where it transitions is affected by this bandwidth control, and if you actually pull it down a little bit, it will actually give you a little resonant peak at the area where it's where the filter is getting cut, which can give you a nice sort of sweeping sound as you move the filter. Okay, so if I leave that set to 0.3 at the moment, and just going to change that back. So that is basically how the static cutoff works. But if we were to change that to player proximity changes cutoff, so currently we are outside of the collision box, so it is going to be filtering out the cutoff is going to be at 20 Hertz. So it's basically filtering everything out at the moment. But if we were to run through, You can hear that we're adjusting that cutoff based on the player's proximity. Okay. So next, I just want to quickly go over some of these other settings here. So we've got two filters, and with this setting here we can change how the two filters are applied in the metasound graph. So for example, when they're set to series, filter 1, the audio will go into filter 1 and it will come out of filter 1 and it will go into filter 2. But you can set that to parallel as well. So in that case, the audio will go into filter 1 and into filter 2 at the same time, and then it will come out of the two filters and then it will be mixed together. So yeah, you can change how it's routed basically. And then we've got this setting, so low end roll off frequency. So what this does is it's essentially another high pass filter. Anything below 300 Hertz, when we set this value to 1, will get cut. So the reason we've got this is because sometimes when you're using a filter with a little bit of resonance on it, you can create a little bit too much bass in the low end, and you can get these horrible resonant peaks. So we can combat that just by rolling off the low end, which is pretty standard in a lot of mixing, to just cut off the low end a little bit. So we've got that option here to be able to do that. Okay. So next, I think we'll have a look at the proximity settings for it. So if you've watched any of the other videos, you'll be familiar already with how the proximity variables are set. So if not, I can just quickly run through it as well for the filters. So each filter has a proximity setting. So when it's set to player proximity changes cutoff, so it has to be set to that. The first one, filter frequency shift curve. So that'll just be basically the curve response between the minimum and maximum value, right? So I normally just keep that set to 1. And then obviously you've got your minimum and maximum frequencies, which control the range as the player moves through. And then we've got this one, we can invert the range, which essentially just flips, it just swaps these two values over. And then we've got values here for which axis we want the filter cutoff to be applied to. So currently we're using the X and the Y axis. So you can, if I just move around it, you can sort of have a look and see what it's actually doing at the moment. So if I was to disable the Y axis, you can see what's going on now, and actually it gives you a better representation of the rainbow when you're not factoring in more than one axis, so you can see it a little bit easier. So it does a sort of calculates, it combines the three and gives you a result. So you can add the Z axis in if you want. And yeah, like the other proximity variables, we've got the ability to change the direction of it. So currently the minimum value would start on the edge and the maximum value would be in the middle. but we can change it to edge to edge. So which one are we on? We're on Y. So if we come down to where it says Y axis edge to edge filtering and enable that, we can see that our range goes from one end to the other end, and then we've got an invert selection, so we can select that and it will flip it in the other direction. So yeah, that is pretty much what the filters do. And just one other thing that's worth mentioning is in filter 2 under general settings, the mix percentage by default is set to 0, okay, because a lot of the time you're only going to want to use one filter, so that's by default it's set to 0. But if you do want to use filter 2, you can just set that to 100, and then it will factor that in as well to the visualizer. Also, there's another one in visual components. We've got filter 1 and 2 visualizer balance. So if you change that, you can set the visualizer to show either filter 2, filter 1 or filter 2, or a mixture of both. And so yeah, that's pretty much it. So we can also show the LFO if we've got that set with this option here. So actually I might just send the LFO to it. So now we can see what the LFO is doing to the filter cutoff by site. And just as an example, we can increase the range on it. So if I was to hit play now, let's see what that sounds like. And turn off filter 2 actually. So set that back to 0. So how that responds is, yeah, it's going to be determined on how you set up these proximity variables. And you can use a combination. I mean, you can add the proximity fade as well to this sound, so that you have more of a smoother transition as you go into the collision box. So I think that covers it for this one. Hopefully that made sense. Thanks for watching, and see you in the next video. Okay, cheers, bye.